Linus Torvalds, the creator of Linux, once said that programming is telling a computer what to do. And this is by far the best definition of programming I've ever heard. It's short and it's perfectly correct. We give a computer some instructions to execute and it does exactly how we described it. Thanks to programming, we can tell a computer to display something, to calculate something, to print out or send something. It might sound a little bit confusing now, but let's think about video games for a moment. Let's imagine an action game where we run, shoot, talk, gain experience points and get new weapons. It all seems to be very complicated, but let's strip it all down to the basics. We press an arrow key and our character moves in a given direction. We press another button, this time the one responsible for shooting, and if we have enough ammunition, we shoot at our enemies. We encounter an enemy, a fight starts, and while our enemy is still alive, he shoots and tries to kill us. I emphasize the words if and while because they have a very special meaning in programming and I will talk about them in a bit. In general, the whole idea of programming is based on three simple concepts. The first thing, statements, and these are simply instructions to execute. So here we have things like when a button is pressed, move a character. When an icon is pressed, save the file. When another icon is pressed, print out the document. The second thing is so-called conditionals or conditional statements, and the name says it all. These are statements we execute if some condition occurs. Yes, this is that if. We press a button and if we have enough ammo, we shoot. If not, we display a no ammo message. Or we press an arrow key. If it's a left one, we move to the left. If it's a right one, we move to the right. The third thing is loops, and basically we have two types of them. The first type is called a for loop, where we execute some statement a defined number of times. For example, we want to go from 1 to 100 and display each number on the screen. The second type is called a while loop, where we have some conditional expression and while this expression is true, the loop goes on and executes what's inside. And this is the whole logic we have in programming. We tell a computer what instructions it should execute and what conditions must be fulfilled to execute those instructions. Of course, we can combine these three things in different ways. We can have a loop inside a loop, we can have a conditional statement inside a loop, or we can execute a loop only when some condition occurs before. But there's nothing more in programming. No matter what we want to program, these three things, statements, conditionals and loops, are all we need. It's also important to explain the concept of an algorithm, because this is how we call this set of instructions for a computer. An algorithm isn't exclusively a computer science thing, because we stumble upon different algorithms every single day. When we cook dinner, we follow the steps of some algorithm. Take 500 grams of potatoes, peel them, if you eat meat, put it in a pan, if not, add tofu instead, and keep stirring everything for 5 minutes. Or when an alarm clock rings in the morning, but we still want to have a little bit of sleep. Take your phone, hit snooze, and repeat it 3 times. Then get up, wash your teeth, go to the kitchen, think for a second if you want tea or coffee. If it's tea, boil some water. If it's coffee, decide if you want a bean or an instant one. If you want an instant one, boil the water. If a bean one, turn on the coffee machine, and so on and so forth. So now the only thing left is a question. How do you write those instructions for a computer? A computer doesn't understand the language that we speak. Actually, it only understands two types of information. 1 or 0. Where 1 means that the current flows through a circuit and 0 means that the flow of current is not present. I won't be getting much deeper now in how computers work, but keeping it very short, inside every computer there are thousands of tiny devices called transistors, which are responsible for processing a current that flows through them. So sending this energy, this is 1, or not sending, this is 0, we give a computer a very precise information. And this stream of 1s and 0s flowing through a circuit may represent text, picture or sound. Actually, all we see and do on a computer on a certain level is that stream of 1s and 0s. Luckily in programming we don't write these 1s and 0s. Instead we choose one of many programming languages and in this language we write our code. I always like to illustrate everything I talk about with examples, so now we'll take a look at a short piece of code written in Python. This code implements a very simple algorithm. We ask a user about their age and we display information if the user can display some age-restricted content or not. As we can see, even if we haven't had an experience with programming before, such code looks quite clear. We can easily understand what's going on. And this is how programming languages look. Using words and expressions defined in a given language, we write instructions for a computer. In the next step, our code is translated by a tool called compiler or interpreter into a so-called machine code. A machine code is a set of instructions that can be understood by a computer, or being more precise, by a processor sitting inside our computer. And this is the processor that is responsible for executing all the instructions. When we think about traditional languages like English, Spanish, German and all the others, we usually think how different they are. They have different words, they have different rules, and they have different grammar. But they all share the same goal. We use them to express how we feel, what we like, what we do, what we did, and what we are about to do. To make it possible, all these languages introduce the same concepts: nouns, verbs, adverbs, adjectives, and different tenses. And when we learn a foreign language, we're not completely lost. We usually know what's the basic idea of a language. We know, for example, that if we want to talk about our plans, we need to use some future tense. It's not like a totally new concept for us, so we can look for similarities and try to use an experience we have with other languages. And it works pretty much the same with programming languages. Of course there will be differences. Different languages might have different syntax, different languages might have different rules, different languages might have different data structures built into them, but they all share the same three concepts I talked about. We'll have statements, conditionals and loops, no matter what language we'll choose. So these are the basics of programming, and that's also all for today, guys. If you want more, don't forget to hit that subscribe button below. Thanks for watching and have a good one.